तो आज बच्चों हम सीक्वेंस एंड सीरीज के स्पेशल एक्सरसाइज के कुछ और एप्लीकेशन करने जा रहे हैं। एक्सरसाइज 9.4 एंड क्वेश्चन नंबर 3, फाइंड द सम टू n टर्म्स ऑफ द सीक्वेंस 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus and so on up to infinity. Find the sum to n terms of the sequence 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus and so on up to n times. This is the question. Find the sum to n terms of the sequence 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus and so on up to infinity. So this is a special type of sequence which is neither an AP nor a GP. So in order to find the sum to n terms of this sequence, we have to find the nth term of this sequence. In this sequence, the first elements are in AP and second elements are also in this special order: 1 square, 2 square, 3 square. Therefore nth term will contain n square, and here 3, 5 and 7 and so on, they are in AP. We can find the next nth term by this AP, nth term of AP, and its nth term will be Tn will be is equal to nth term of AP 3, 5, 7, dot multiplied by n square. This will be the nth term of this whole sequence. Nth term of this AP multiplied by n square, 1 square, 2 square, 3 square. Therefore in nth term it will be n square, and its nth term is 3 plus n minus 1 into 2 into n square, and that will be is equal to 3 plus 2n minus 2 into n square. It will be is equal to 2n plus 1 multiplied by n square. This will be the nth term of this sequence, and it can be written as 2 into n cube plus n square. This is Tn. Nth term of this sequence becomes this 2 into n cube plus n square. In order to find the value of Sn, we have to take sigma Tn. Sigma Tn means sigma 2 into n cube plus sigma n square. And after putting the value of sigma n cube and sigma n square, we will get the sum to n terms of this sequence. Now let us find Sn. Sn will be is equal to sigma 2 into n cube plus n square. That will be is equal to 2 into sigma n cube plus sigma n square. Therefore Sn will be is equal to 2 into n into n plus 1 upon 2 whole square plus n into n plus 1 into 2n plus 1 upon 6. After calculating this value, we will get the sum to n terms of this sequence. It becomes 2 into taking n into n plus 1 upon 2 common, we get n into n plus 1 upon 2, we get 2 into n into n plus 1 upon 2 plus 2n plus 1 upon 3. Therefore, n into n plus 1 upon 2 and to cancel it, we get n square plus n upon 1 plus 2n plus 1 upon 3. And taking 3 LCM, we get 3n square plus 3n plus 2n plus 1. This becomes this. And the answer of this question will be equal to n into n plus 1 upon 2 into 3n square plus 5n plus 1 upon 3. And therefore, the answer will be equal to n into n plus 1 into 3n square plus 5n plus 1 upon 6. This is the answer of this question. And this is very important questions for examination as well as computation point of view. That's all. Find the sum to n terms of the sequence 1 upon 1 plus 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus and so on. In this question, we have to find the value of Ti first of all. First term is 1 upon 1 plus 1 into 2. Second term is again numerator 1. Therefore, in the nth term there will be 1. And in the nth term, in the first term there is 1 into 2, second term 2 into 3, third term 3 into 4. Therefore, in the nth term n into n plus 1. This will be the nth term of this sequence. And this sequence can be written as 1 upon n minus 1 upon n plus 1. These are called partial fraction of this term. 1 upon n into n plus 1 can be written as 1 upon n minus 1 upon n plus 1. If we take the LCM, we will get after calculation the same thing. Therefore, breaking this as, this is nth term of this sequence. Now, Sn. Sn will be equal to sigma Tn, that will be equal to sigma 1 upon n minus 1 upon n plus 1. That is further equal to, now putting the value of n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and so on, n is equal to n. Here we get 1 upon 1 minus 1 upon 1 plus 1, that is 2. In the second term, putting 2, 1 upon 2 minus 1 upon 3. Therefore, putting n is equal to 3. 1 upon 3 minus 1 upon 4 plus dot dot dot, and at last putting n is equal to n, we get 1 upon n minus 1 upon n plus 1. And if we are interested to write the previous term, then putting n is equal to n minus 1 here, we will get 1 upon n minus 1 minus 1 upon n. Or that minus 1 upon n will cancel this. If we write the previous term, here we will get minus 1 upon n. And that will cancel this 1 upon n. plus 1 upon n. And all the previous terms get cancelled. Minus 1 by 2 plus 1 by 2. Minus 1 by 3 plus 1 by 3. Minus 1 by 4 यहाँ पे plus 1 by 4 आएगा. और ये plus 1 by n will be cancelled by the previous term, last term यहाँ पे minus 1 upon n ये भी कट जाएगा. This and this will be remaining, that is 1 upon 1 minus 1 upon n plus 1. That is equal to n plus 1 LCM, and we get n plus 1 minus 1, and answer of this question is n upon n plus 1. This will be the value of Sn for this question. This question is also very important for competition as well as board point of view. That's all. Now question number 9. Find the sum to n terms of the sequence whose nth term is n square plus 2 raised to power n. In this question, nth term is already given to you. You have to take sigma of nth term to find the sum to n terms. Simply it is Tn. According to the question, Tn is equal to n square plus 2 raised to power n. Therefore, with applying the formula, Sn is equal to sigma Tn. That is sigma n square plus 2 raised to power n. And it becomes sigma n square plus sigma 2 raised to power n. Sigma n square, the value is n into n plus 1 into 2n plus 1 upon 6 and plus 2 raised to power n becomes 2 raised to power 1, 2 raised to power 2, 2 raised to power 3 plus dot 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 up to n times. It is a GP whose first term is 2 and common ratio is also 2. Hence we can find its value simply by applying the formula Sn is equal to A into r raised to power n minus 1 upon r minus 1, because r is 2 which is greater than 1. Therefore, it becomes Sn is equal to n into n plus 1 into 2n plus 1 upon 6 plus A is 2, 2 raised to power n minus 1 upon 2 minus 1. Applying the formula, Sn is equal to A into r raised to power n minus 1 upon r minus 1 if r is greater than 1. Hence the answer of this question becomes n into n plus 1 into 2n plus 1 upon 6 plus 2 into 2 raised to power n minus 1 upon 1. That is the answer of this question. Very easy. If nth term is given, then it is very easy to find its sum to n terms of such type of sequences. That's all.